everyone. Today teacher going to share about chapter 15, which is about sexual reproduction, development and growth in humans and animals. But teacher going to focus on 15.2 only, which is about gametogenesis in human. Right? So first, let's see about the learning outcomes. So for this subtopic, we're going to discuss about the necessity of gametogenesis, and then we will describe about the gamete formation, which is spermatogenesis and oogenesis, and lastly, we will compare and contrast between the spermatogenesis and oogenesis. Every time before you go through or do your revision, please go through the learning outcomes so that you know what you're trying to focus and what you have to focus on. Alright, so first, what is the necessity of gametogenesis? So what is the gametogenesis? This is the process of production or to produce reproductive cell, or we call it gamete. This what about gametogenesis? And this happen, all the gamete that produce must be haploid, and the process take place in gonad. So for male gonad will be your testis, and for female is the ovaries. So when the fertilization take place, the nucleus of sperm will fuse with the nucleus of ovum in the fallopian tube. Then you will form the diploid zygote. Alright, so how do we answer the question when they ask you what are the necessities of gametogenesis? So you have to slightly modify the sentence, right? So first, of course, gametogenesis is to produce gametes. That's what it's all about, right? So we produce gametes, and all these gametes must be haploid. And this is very important to maintain the diploid chromosomal numbers of zygote. And through this zygote, through this gametogenesis, you will also produce genetic variation either in gametes or offspring. Also, these are the four importance or necessities of gametogenesis. What if we have negative question? For example, here, what could possibly happen if gametogenesis does not take place? When we have negative question like this, we must come with negative answer. Alright? So, no gametes. We will mention that about no gametes will be produced. When there's no gametes, no fertilization take place. No fertilization take place, no zygote will be produced, and lastly, it will lead to extinction. So remember, whenever a question asks you the negative question, you must answer in a negative way. Right? Next, now straight go to spermatogenesis. So what is spermatogenesis? This is the process of sperm production that takes place in the seminiferous tubule. Okay, so this is the longitudinal section of the testis. So we'll go through all this tube, a lot of tubes over here. This is what we name as seminiferous tubule, which is the actual site of spermatogenesis occur. So this is where we produce all the sperm. After that, once the sperm is produced, is going to store in the epididymis. This is where we store the sperm. And lastly, during ejaculation, sperm will leave the testis through the sperm duct. Number 3, this is the sperm duct, or we also call it as vas deferens. Okay. So next, we will go to the cross-section of the seminiferous tubule. This is the cross-section. So this is where our spermatogenesis will take place. It actually happens at the wall of the seminiferous tubule. And then once the sperm are produced, then they will gather in the lumen. In the center of it, they will gather in the lumen. Okay. So before we proceed with the process, let's go through the name first. So this first, they'll form the primordial germ cell. Then we have spermatogonium. And then primary spermatocyte. secondary spermatocyte, spermatid, and lastly we have sperm at the lumen. Okay, how are we going to memorize all these names? Or before that, we also assist by the Sertoli cell, where you will provide the nutrients throughout the process. Okay, so teacher come with a mnemonic to memorize this. Pisang goreng bakso tak masak. So P for primordial germ cell, which is diploid. G for spermatogonium, gonium. And then P, Pak for primary spermatocyte. And SU, S for secondary spermatocyte. Ta, T for spermatid. And M for sperm. M for sperm. So pisang goreng bakso tak masak. So by using this flowchart, actually it's quite easy. You just, first of all, you use this mnemonic. Pisang goreng bakso tak masak. Then you can see that we have 6 boxes over here. First 3 are all diploid, and then followed by haploid, All right. So this is how you remember the chromosomal numbers. And inside here also we have 3 phases, which is multiplication phase, growth phase, and maturation phase. I have a typo over here. Okay. Next. All right, so first we go to a multiplication phase first. So here, what happened in this phase? First, spermatogenesis begins as the primordial germ cell, which is diploid. Then, it will undergo the process of mitosis to produce spermatogonium, which is still diploid, over here. And then spermatogonium is going to expand and grow and form the primary spermatocyte here, which is haploid. So in growth phase, each primary spermatocyte, which is diploid, will undergo meiosis 1. To form 2 secondary spermatocyte, which is haploid. In numbers. All right. Next, this is the maturation phase. So during the maturation phase, each secondary spermatocyte will undergo meiosis 2, and you will produce 2 spermatid, which is haploid. So from 1 spermatogonium, now we already have 4 spermatid over here, which is haploid. Will form 4 spermatid, which is haploid. And you can see that these spermatid actually are immature and does not develop into this special characteristic of the sperm, which allow it to perform its function of fertilization. So now all these spermatid will undergo the process of differentiation, and now finally we will form the sperm. We have sperm, which is haploid. So these sperm, we can see that clearly that they have the head, they have the midpiece, and the tail. And then this structure is going to enable them to swim and fertilize the secondary oocyte. Okay, secondary oocyte. And then throughout the spermatogenesis, we also have some helpers actually. Like for example, first, Sertoli cell. Sertoli cell is going to provide nutrients in the process of spermatogenesis, and will assist by 3 hormones. First, it will, which is our follicle stimulating hormone. Second is our testosterone. So this FSH and testosterone will stimulate spermatogenesis. And then we have the luteinizing hormone, LH, which will stimulate the testosterone secretion in the testes. All right, so this is all about spermatogenesis. Okay, next, let's go through the female reproductive organ before we go to our oogenesis. So for female reproductive organ, we can see that we start from vagina, and then you have the cervix. This is our uterus, fallopian tube, where we're having our fertilization, and then lastly there's ovary. So teacher also have a mnemonic for us to help you to memorize this. So which is VCUFO, vagina, cervix, uterus, fallopian tube, and lastly ovary. Okay, so let's proceed with oogenesis. So what is oogenesis? Oogenesis is the process of secondary oocyte or female gametes production, and it takes place in the ovaries. So it's slightly different from the spermatogenesis, where the oogenesis actually begins in the female's ovaries before they are born. And there are actually two events happen at the same time, which is the meiotic events and the development of follicle. So before proceed to the process, let's go through the name first. So just like the spermatogenesis, teacher use pisang goreng bakso tak masak. So for oogenesis, we only need 4 of that. So which is pisang goreng bakso. So if spermatogenesis, we have spermatogonium. So for oogenesis, we will have oogonium, and spermatocyte for spermatogenesis. For oogenesis, we'll have oocyte. So from primordial germ cell, form oogonium, and then primary oocyte, secondary oocyte, and then ovum. All right. So this is the name that you have to memorize for this process. Okay, let's go to the oogenesis process. So oogenesis process actually happen at the fetal stage. So before birth, this primordial germ cell, which is diploid, will undergo mitosis. Mitosis, and then you will form oogonium, which is still diploid, which is still diploid. Diploid, and then this oogonium will then develop and then grow and then form the primary oocyte. Primary oocyte, and still primary oocyte are still diploid. They are still diploid. Okay, and then this primary oocyte will begin meiosis 1. Meiosis 1, but this process will stop at prophase 1 during the fetal developments. Okay, so before birth, we actually have like around 7 millions of primary oocytes. After birth, it left only like around 1 million of primary oocyte only. Okay, next. So after puberty or after the female reach the puberty, the primary oocyte will reduce to around 300,000. So upon reaching the puberty, the prophase 1 will continue, and the meiosis 1 to form the secondary oocyte. Now you can see the secondary oocyte is haploid. Here they have actually formed from the primary oocyte, it formed two haploid cells. So you can see this one is slightly smaller, with less cytoplasm. So this is what we call as first polar body, and then this one, which is larger, we call it as secondary oocyte, which is haploid. Then this secondary oocyte will start to carry on with meiosis 2, and then stop at metaphase 2. And this secondary oocyte is going to remain in metaphase 2 or the stage until a sperm penetrates it. A sperm penetrates the secondary oocyte, and then this meiosis 2 will be complete. When this meiosis 2 complete, the secondary oocyte will become same. Here we have 2 cells, so the smaller one will be the secondary polar body, and while the bigger one is our ovum, which is haploid. So what happened to this first polar body? So this first polar body is either degenerate, or it will also undergo the meiosis 2, and then lastly it form the polar bodies. And lastly, all these polar bodies will be degenerate. Okay, so next we shall proceed with the follicle developments. Okay, so after birth, After birth is to remember, primary oocyte will stop at prophase 1. Then it will actually cover with this layer of follicular cell, a layer of follicular cell. So this combination, the primary oocyte and the follicular cell, will form, or we call it as the primary follicle. Primary follicle. And then after puberty, after puberty, with the help of follicle stimulating hormone, FSH actually stimulate the growth of the follicular cell. And then you can see here, you actually form few layers of follicular cell. And so when primary follicle will continue meiosis 1 and you form the secondary oocytes. This secondary oocyte will encapsulated in the layers of this follicular cell, and then you will form this secondary follicle. And then this secondary follicle will continue to grow and develop and then form the Graafian follicle. This Graafian follicle will release estrogen. Okay. Then this Graafian follicle is ready for ovulation. So during ovulation, secondary oocyte is released into the fallopian tube. So what happened to the follicular cells? So the follicular cells that left will develop into corpus luteum. This corpus luteum will continue to grow and secrete estrogen and progesterone if fertilization takes place. If this doesn't take place, it failed to happen, this corpus luteum and secondary oocyte will degenerate and dies, and lastly remove through the menstruation. All right. So again, this oogenesis in the ovary. So oogonium will develop into the primary oocyte, and then it will encapsulated with the follicular cells, and you will form primary follicle. Primary follicle will undergoes meiosis, and stop at prophase 1. After that, after puberty, the primary oocyte will continue the meiosis 1 and form secondary oocyte with the help of FSH. So the follicular cells are developed, and this secondary oocyte will encapsulated with the layers of follicular cells, and now you have secondary follicles. Then this secondary follicle will develop and form Graafian follicle. It will form Graafian follicle, and during ovulation, the secondary oocyte is released into the fallopian tube. And this follicle cell left will develop and form corpus luteum. Okay, so this oogenesis. So a very fast revision on this spermatogenesis. So again, pisang goreng bakso tidak masak. So we start from your primordial germ cell, which is diploid. Okay, then you will undergo few times of mitosis. Then you will form spermatogonium, which is diploid also, and it will actually grow and develop and form primary spermatocyte, which is diploid. Okay, after this primary spermatocyte is going to undergo meiosis. After meiosis, it will produce two secondary spermatocytes, which is haploid, and each of these secondary spermatocytes will undergo meiosis 2, and each of it will produce two daughter cells, which is also haploid. And this cell we name it as spermatids, which is an immature cell which cannot carry out fertilization. So this spermatid, which is haploid, will undergo differentiation, and lastly, we'll have four haploid sperm form. So this is about spermatogenesis, and here is the summary for the oogenesis. Okay. So now, let's compare between spermatogenesis and oogenesis. So both of these are gametogenesis. So Both spermatogenesis and oogenesis produce haploid gametes. So how do you produce haploid? Of course, it will involve the process of meiosis. It will involve the process of meiosis. And where did this take place? Both will take place in the gonad or reproductive organ. So we already have three similarities for spermatogenesis and oogenesis. Next, let's go to the differences. Okay, so spermatogenesis and oogenesis. From the name, we also know that spermatogenesis is the process that produces sperm, while oogenesis will produce secondary oocyte. And then where did this take place? Spermatogenesis happened in testes, while oogenesis in ovaries. My mistake, typo, in ovaries. So what happened is the sperm are smaller and made up of head, midpiece, and tail, while the secondary oocytes are larger and spherical in shape. Okay, these are sperm and secondary oocyte. And teacher just said just now, each spermatogonium will produce 4 sperm after meiosis, while oogonium only produce 1 secondary oocyte and 3 polar bodies. And meiosis from here, meiosis. So meiosis is complete for spermatogenesis, while for oogenesis, it only complete when a sperm fertilize or penetrate the secondary oocytes. Okay, so we already have 5 differences over here. And next, spermatogenesis. Just now we know that it becomes immature first before it becomes sperm. So spermatid must undergo differentiation before it becomes sperm, while secondary oocyte does not undergo differentiation. And for spermatogenesis, millions of sperm are formed every day, while oogenesis, only one secondary oocyte is released from the ovaries at every menstrual cycle. And for spermatogenesis, is a continuous process from puberty until old age, while for oogenesis, this production only starts in the female fetus and continuous once the female reach puberty, and only stop during menopause. Right? So we have 3 similarities and 8 differences. Okay, I think that's all from me now. Okay, thank you and bye.
Now, these are the 2 keywords you must have in your definition. So now, how to make it easy for us to remember the definition? Now, if we ask girls, I'm sure girls will tell menstrual cycle is so wonderful. Isn't it, girls? Okay, it is so wonderful, right? Okay, of course it is wonderful. Why? Because it allows us to have offspring. Okay, if there is no menstrual cycle, no ovulation, no fertilization, and we can never continue with our species, correct? So yes, menstrual cycle is so wonderful. So I'm going to use that as our clue for the day. So we're going to use this phrase, so the wonderful. I'm going to take S-O, so the wonderful. Right? S-O-T-E-W for so the wonderful. Now, why teacher use this phrase? S-O for secondary oocyte and T-E-W for thickening of endometrium. Now, let's try that. How do we define menstrual cycle? We go back to our catchy phrase, so the wonderful, so the wonderful, SO for secondary oocyte, TEW for thickening of endometrial wall. Now let's construct that into a sentence. The menstrual cycle involves production of secondary oocyte and thickening of endometrial. Now that we are done with definition, we are going to go and tackle the next component in this subtopic, which are the hormones. Right. Now class, for menstrual cycle, now let's see how we can make it easy for us to remember all those hormones, their glands and their functions. Okay. Now let's look into our clue here. Okay. How to memorize the hormones? Teacher come up with a short phrase. Hippo and giraffe follow the penguin. Hippo and giraffe follow the penguin. Okay. Now, why hippo and giraffe follow the penguin? Because teacher want to use, right, the alphabets there. HYPO for hippo, GR for giraffe, FLO for follow, and penguin, P for penguin. Okay. Now, let's repeat that again. Repeat the phrase again. Hippo and giraffe follow the penguin. Hippo, giraffe, follow. Okay, now let's see how this small catchy phrase is going to help us memorize the hormone. Let's tell the phrase again, class, one more time. Hippo and giraffe follow the penguin. Okay. This giraffe does not look that cute, right? Let's change it. Ta-da! Okay, now this one looks much better, isn't it? Okay, right, now again, hippo and giraffe follow the penguin. So let's take out the important alphabets from there. Hippo, GR for giraffe, FLO for follow, the penguin. Okay, right. I'm going to use all these 4 alphabets here, okay, in these 4 boxes here to help you relate to the hormones. Okay, hippo and giraffe follow the penguin. Now this HY here stands for hypothalamus, P for pituitary, and O for ovary. So this hippo is going to help you memorize all the 3 glands. Now HY or hypothalamus secretes gonadotrophin. I repeat, hypothalamus secretes gonadotrophin releasing hormone. Pituitary secretes FNL, which is for FSH, follicle stimulating hormone, and LH, luteinizing hormone, and ovary releases OP. Now that we have looked into all the glands and the hormones, now let's look into the function of the hormones secreted by this each gland. We'll start with hypothalamus. Hypothalamus secretes gonadotrophin. Okay, we just looked into that earlier, the earlier slide. Now class, this hypothalamus releases or secretes this hypothalamus secretes gonadotrophin releasing hormone. What is the function of this gonadotrophin releasing hormone? When hypothalamus secretes gonadotrophin, this hormone will be used to stimulate pituitary. So gonadotrophin is going to stimulate its hormones. Now let's look into hormones in pituitary. Pituitary will release 2 important hormones, which is FSH and LH. FSH or follicle stimulating hormone, the function is to stimulate follicle growth. So you can relate to the name itself. Okay, you can relate to the name itself. Follicle stimulating hormone is to stimulate follicle. Okay, and as follicles grow, these growing follicles will release estrogen. Right, the bigger or the larger the growth of the follicle, the size of the follicle, the higher the amount of estrogen that will be released. So this is also like a win-win situation where follicle grow releasing estrogen. When estrogen is more, the follicle will grow even more, and they start releasing more estrogen, and the follicle grow even bigger. So can you see that, class? Like I help you, you help me, like that. Okay, so this is both related. The growth of the follicle and the release of estrogen here is interrelated. Now we go for LH, okay, which is the luteinizing hormone. Okay, LH has 3 important functions. The first one is to stimulate ovulation. LH at its peak, that means at the highest level, okay, LH at its highest level will stimulate ovulation. after ovulation, what happened? The empty bag, okay, the empty graphene follicle will form corpus luteum. So LH is also important to ensure that the graphene follicle forms corpus luteum. And then this corpus luteum will release. Let's look into how to simplify all of this. Okay. Everything related to pituitary. What are the hormones? What is the function of this hormone? Okay, right. So to help us memorize pituitary, I'm going to use this another phrase, okay, which I call as Pergi Finland. Okay, I'm sure you have heard a lot about Finland, kan? Very nice place, quite successful, and then they have great ideas in those countries. So if you want to learn something new, you can make sure Finland is in your bucket list lah. Okay, one of the place for you to visit. Okay, so pergi Finland for orang cari pengalaman. Okay, right. Why teacher use that phrase? Because again, I want to use the alphabets to help us with this gland. Okay, you can even change that OCP. What I actually want here, class, is the PFL from Pergi Finland, FOR from the for, and OCP from the orang cari pengalaman. You can change this OCP if you want. If you think orang cari pengalaman so blunt like that, okay, never mind. You can change this. Maybe we can say pergi Finland for original chicken pie. Okay, you can say that. Okay, anything that makes it easy for you to remember the phrase. Okay, so let's say pergi Finland for original chicken pie. Okay, so how to relate to this pituitary? Okay, right. P for pituitary, and pituitary will release its two important hormones, F for FSH and L for LH. So F for follicle stimulating hormone and L for luteinizing hormone. So this Pergi Finland PFL is for pituitary and the two hormones, right? Okay, now let's focus on 4. 4 is starting with F, so which means we are talking about FSH. Okay, for FSH, teacher going to use short form FOR. Okay, FOR. The F here stands for stimulating follicle growth. The F stands for follicle growth, and the OR stands for estrogen release. The ER stands for estrogen release. So FOR for FSH, follicle growth and estrogen release. Now for LH, on the other hand, teacher want to use OCP. Orang cari pengalaman, original chicken pie, right? Okay, OCP. Okay, how to relate this OCP with LH? O for ovulation, C for corpus luteum. Let's proceed into ovary. Okay, ovary is the last gland here related to your menstrual cycle here, okay, that we're going to discuss today. Okay, ovary also releases its hormones, which are estrogen and progesterone. Okay, both estrogen and progesterone, okay, now teacher want you to see here, I know both estrogen and progesterone, they are related to endometrium lining. Okay, both related to endometrium lining. So sometimes we are confused, right? Okay, which one for which hormone? Okay, estrogen is always about repairing. Okay, estrogen is for repair. So kita boleh take the O in front. Okay, we take the O in front. The O is to repair. Dari kosong, kita build up repair. Okay, dari kosong. From zero, we build up, we repair, we rebuild. Okay, from zero. Okay, so repair. Okay, estrogen is to repair endometrium, while progesterone is to progress. Okay, progress, further progress. It thickens the endometrium. Sudah repair, we continue with the progress. Faham ya class? I hope that helped. Okay, right? Estrogen and progesterone. So both, yes, related to endometrium, but estrogen for repairing, progesterone for thickening. Now let's look into the function again one more time. Estrogen repair endometrium, and estrogen also stimulate follicle growth. Okay, as the endometrium is getting repaired, it makes sure the follicles are growing. Okay. Progesterone, okay, after repair, progesterone will ensure the thickening of endometrium. Okay, why thickening? We want to thicken it, we want to stock up a lot of blood, nutrients, oxygen. Why? This endometrium lining is preparing for implantation. They are preparing for implantation, waiting for the embryo to arrive. So they're actually preparing everything. It's like when you're going to receive a very important guest to your house, right? You make sure the house is clean, you make sure there's enough water, food, a nice place for them to rest. That is what the endometrium is actually doing. Stocking up all they need for the VIP to arrive. Right? Okay, let's go through progesterone one more time. Okay, so progesterone is to stimulate thickening of the endometrium, and they also, when this progesterone is high, right class, when this progesterone is high, it will stop release of FSH and LH. Now here, let us see how you can relate all the hormones and functions related to ovary. So for here, let's make it a little bit simple for you to remember. Ovary, okay, releases two hormone, estrogen and progesterone. Okay, so the function, to memorize the function, teacher going to take 3 letters, okay, from the hormone's name itself. Like estrogen, teacher going to take the OES from the estrogen, the first 3 letter OES. Okay, now this OES will help you to relate the hormone to its function. Now this OES stands for, first O, repair. As teacher mentioned to you, repair, rebuild from zero, right? Okay, so this O in front here represents from zero, starting from zero. So repair. What are they repairing? Endometrium. OE. Repairing from zero the endometrium, because repairing of endometrium starts after menstruation, after all the endometrium tissue has been shaded off. So it is going to start from scratch lah, we should say kan, from zero. So 0E, repairing the endometrium. Okay, and then S for stimulating. Now class, stimulate, there are 2 types of stimulate here related to estrogen. Okay, stimulate follicle and stimulate hormone. Stimulate follicle is stimulating the primary follicles into secondary and Graafian. Whereas stimulate hormone, they are going to stimulate FSH and LH to continue with the secretion. So we go through that one more time. Okay, OES, OE for repairing from zero endometrium. S for stimulate. Stimulate, we have 2 here. So you can add on in your handout. Okay. Stimulate, we have 2. One stimulate follicle, another one stimulate the hormone H. Okay. Now that's with estrogen. Now let's progress to progesterone. For progesterone, teacher will take 3 letters from the name itself, which is STE, progesterone. Okay, I'll take STE. Let's see how that STE help you. S for stop the hormone. Can you see the difference, class? Estrogen is stimulating the hormone, while progesterone stops the hormone. Okay. Okay, now that we have finished definition and also hormones, now we can go into the third component, which is relating the stages of events, where we want to look into follicle growth, we want to look into endometrial tissue, as well as the hormonal changes. Usually this is related to menstrual chart. Okay, we want to look into changes throughout a menstrual phase. That means starting from, this is menstrual chart for a cycle of 28 days that starts on day 1 up to day 28. Okay, day 1 up to day 28. But then you need to know that the changes, okay, or the hormonal changes, they don't actually start on day 1. It actually starts a day earlier than the menstruation date. Okay, the changes in the hormone that initiates the menstrual cycle starts 1 day earlier, okay, or 24 hours earlier than the first day of menstruation. Okay, now this menstruation or the menstrual cycle can be divided into 4 phase. I start with the first one, day 0 to day 5, day 0 to day 5, which is menstrual phase. Okay, this is when the female will be menstruating. Okay, so when I say menstruating, what are the points there? Shedding of endometrium tissue. Okay, all the stocked up endometrium tissue now is of no use, right? Okay, because there is no fertilization, no implantation. So they are actually clearing off all the old stock. So together with this stocked up oxygen, blood vessels, and also their nutrients, they will also shed off the date ovum. So in this discharge, it contains uterine tissue and the date ovum. Now, at the same time, okay, while the endometrium line is shedding off the old stock, in the ovary, okay, let's see what happened inside the ovary. In the ovary, the follicles will be growing. Okay, it already starts with the follicle development, where slowly the primary oocyte that the female is born with, okay, the females are born with certain number of primary oocytes. So this primary oocyte will start to slowly grow into secondary oocyte. Okay, this is what is happening, the important ones lah, okay, of what's happening during menstrual phase. Now let's go to the next phase, which is the repair phase. Repair phase from day 6 to 11. Okay, what happened here? This is repair. Okay, so as what you know, the old stock has been shaded off. So now they are going to form new stock. So they're going to form new uterine tissue. So this is what we call as repairing endometrium tissue or endometrial wall. Okay, so what happened to the endometrial wall is getting repaired, rebuilt with new stock. Okay, what happened inside the ovary? Let's not forget the ovary. What happened inside the ovary? Now the secondary oocyte is slowly growing into a large Graafian follicle. So I want you to look at the changes, right? Okay, within these 2 phases, look at what's happening inside ovary. Ovary started off as primary, developed into secondary, and by the end of the, I wouldn't say the end, by the mid of the end of your second phase, sorry. Okay, by the end of your second phase, it is already developing from secondary into a large Graafian follicle. Primary to secondary to Graafian. Okay, next we move on to the next phase, which is from day 12 to day 18, which we call as fertile phase. Okay, why fertile? Fertile in Bahasa is subur. Okay, subur. Why we call this as a subur timing? This is because the female will have ovulation. Okay, she will ovulate on day 14. On day 14, that's ovulation. Okay, and then there is also continuous thickening of endometrial wall. Whatever repaired in the second phase will continue to thicken during the third phase. Okay, so what happened in the wall? The endometrium wall continued to thicken. What happened in the ovary? Ovulation on day 14. Okay, next, move on to the last phase. Okay, now what we are going to do, we are going to look into every phase of the menstrual chart separately so that we can see the relationship between the hormone level, the follicle development, and the endometrial wall. Because when you need to answer essay section, you need to relate these 3, right? You need to relate all these 3. Okay, So menstrual phase is from day 0 to day 5, okay, where it starts with hypothalamus secreting gonadotrophin. So it will usually start at day 0, okay. Why not day 1? Because it starts a day earlier. It starts a day earlier than your first day of menstruation. So it starts at day 0, where gonadotrophin, okay, will be released by hypothalamus. Gonadotrophin will stimulate pituitary, and pituitary will secrete FSH. Okay, right. So you can see here FSH level, okay, gonadotrophin stimulates pituitary, pituitary releases FSH. Now we look into the second phase, which is the repair phase. Okay, so repair phase, we are looking into approximately the second week of menstruation. Now, during the repair phase, estrogen released by the follicles will start to repair the endometrial wall. Okay, so you can see that the endometrial wall slowly starts to repair. Okay, as it is repairing, okay, as the estrogen level, so you can see here, let's relate estrogen level. Estrogen goes up, repairing also works. Repairing also is being carried out. Okay, estrogen level increase, the repairing work starts. Okay, next. Estrogen level rises, and this high level will stimulate hypothalamus. Stimulate hypothalamus for what class? To secrete gonadotrophin. So this is the second time gonadotrophin is being released by the hypothalamus. Now this second secretion is to stimulate pituitary again. Okay, first time pituitary gets stimulated is for follicle stimulating hormone, kan? So that it can start the development of follicle. Now the follicles are growing big, okay. The second secretion of gonadotrophin is to stimulate pituitary to release LH, the second hormone from pituitary. Okay, right. That's when here you can see the level of LH increasing. Okay, you can see the level of LH increasing. Okay, so this. Now during the third phase, which is usually from day 12 to 18, approximately the third week, okay, this is known as a fertile phase. Okay, why fertile phase? Let's look into the changes. In fertile phase, okay, LH rises. As I showed you in the previous slide, you can see the LH rise. The LH is going to reach its peak, paling tinggi, the highest concentration. Okay, as LH rises, it will stimulate ovulation on day 14. So you can see here on day 14, Graafian follicle ruptures, releasing the secondary oocyte. So that's ovulation, right? Rupturing of Graafian follicle, releasing secondary oocyte into fallopian tube. Okay, that's why we call it as a fertile phase. Okay, because there is chances of pregnancy. There's possibility of the female to produce offspring during this phase. Okay, now let's see what happened after ovulation. After the Graafian follicle ruptures and releases the secondary oocyte, what happened to the Graafian follicle? The Graafian follicle is now empty. It's an empty bag. Okay, bag yang kosong. Okay, empty bag. So this empty bag is now turning into corpus luteum. This empty bag forms corpus luteum. After secondary oocyte is out, we don't call it into as a follicle anymore. It's corpus luteum. Okay, now this corpus luteum will release estrogen and progesterone. Okay, it will release estrogen and progesterone. So you can see here, class, okay, estrogen level is increasing. You can see progesterone level is increasing. Okay, this is coming from corpus luteum. Okay, right. Now, as the progesterone level increases, okay, FSH and LH will be inhibited. That means it stops the release of FSH and LH. And it now in this slide, we are going to look into the last phase or the last week of menstrual cycle, okay, which we call as premenstrual phase. Okay, now let's see what happened during premenstrual phase. Now this premenstrual phase, it relies on two different situation or two different scenario, depending on whether fertilization took place or not. Okay, if there is no fertilization, okay, let's say there's no fertilization. Now what happened here? LH level will decrease. You can see the luteinizing hormone decreasing after ovulation. Okay, it is decreasing. As the LH level decreases, what will happen? Corpus luteum will start to degenerate. Apa maksud corpus luteum degenerating? It becoming smaller. Look at the size. Slowly becomes smaller. Itu maksud degenerate. Okay, as LH decreases, corpus luteum degenerates. And when the corpus luteum is becoming smaller or shrinking, you don't see much estrogen and progesterone, okay, being released by this corpus luteum. So progesterone and estrogen levels starts to drop. What happened when estrogen and progesterone level drop? Endometrial wall will start to break down and shed. Okay, so this is going to be the beginning of the next menstruation stage. Okay, this is if there's no fertilization. Now let's say fertilization occur. Okay, if fertilization do happen, then what will happen here? Okay, corpus luteum will continue to grow. So if fertilization do happen, then corpus luteum will not degenerate. It will not become smaller. It will maintain the size. Okay, it will maintain the size. Okay, estrogen and progesterone will be continued. Okay, the release of these two hormones will be continued. So you see the graph, okay, progesterone will maintain high. It will not decrease. Okay, same goes to estrogen. As progesterone is... Okay, now what teacher did just now, I break it based to each different phase. Now I'm going to show you the entire changes for hormonal in one complete menstrual cycle. Okay, we start with gonadotrophin, releasing hormone being released from hypothalamus on day 0. Okay, day 0, hypothalamus secretes gonadotrophin. Gonadotrophin releasing hormone will stimulate pituitary to release FSH. So let's look into that. Pituitary will secrete FSH. What will this FSH do? FSH, when it is increasing in concentration, it will increase growth in the follicle. The higher or the more FSH, the more follicle growth. So I've shown you here the relationship. FSH tinggi, follicle pun jadi bigger. Okay, follicle becomes bigger. Okay, now it continue to grow, and this growth will continue to secrete LH, which is your luteinizing hormone. So FSH increase, follicle grow bigger, and LH also increases. So look at the relationship. Can LH also increase? Okay, now that will trigger ovulation. As you can see, as LH surge occurs, okay, or LH is increasing, we call this as LH surge. S-U-R-G-E. Okay, LH surge means it's suddenly increasing towards its peak. Okay, that will trigger ovulation, and so ovulation happens on day 14. Ovulation happens on day 14. Okay, after ovulation, what happened to the hormone? FSH and LH will decrease. You can see LH decreasing. You can see FSH decreasing. Where's the FSH? This green line here. Also decreasing. Okay, right. On the other hand, estrogen and progesterone will increase. So you can see estrogen increasing and progesterone also increasing. Okay, so after ovulation, hormones from pituitary will be suppressed. Hormones from the ovary will be stimulated. Okay, and this will continue with thickening of endometrium wall for implantation. So as the progesterone increases, you can see as it increases, the endometrium wall will also increase, preparing for implantation. This is the entire hormonal changes for the whole of menstrual cycle. Now let's look into oocyte and follicle development. Okay, teacher going to show you the whole changes throughout one whole cycle. Okay, so what happened here? As FSH is being released, FSH is follicle stimulating hormone, so it is going to stimulate the follicles to grow. So they are going to grow from primary into secondary and continue into a giant size graphene follicle. So you can see a giant size graphene follicle here. So graphene follicle is now ready, and on day 14 ovulation occurs. Okay, where this graphene follicle will rupture, releasing the secondary oocyte. After ovulation, what happened to this graphene follicle? No more oocyte in it. It becomes an empty bag. So what happened to the empty graphene follicle? It becomes corpus luteum. It forms corpus luteum. Okay, so the empty graphene follicle after ovulation becomes corpus luteum. And this corpus luteum, okay, what happens to this corpus luteum depends on whether fertilization occurs or not. If fertilization occurs, then this corpus luteum will continue to grow. It will maintain its size because they are preparing for pregnancy. Okay, but if fertilization does not occur, no fertilization, okay, they will get the signal that there has been no fertilization and corpus luteum will start to degenerate. When it degenerates, level of progesterone and estrogen will also decrease, and that is. Now let's look into endometrial changes. Okay, also for one whole chart. Okay, so here during endometrial changes, okay, what happened day 1 to day 5? Here we are talking about menstrual phase. So the female is actually experiencing menstruation. So this will cause shedding of endometrial wall. The endometrial wall breaks down, okay, and it gets shaded down. It gets removed together with the date ovum. Okay. After the 5 days, when we move on to the second stage, what happened? You can see endometrium wall starts to repair. So it starts to repair. Okay, right. On day 14, again on day 14, we have ovulation. Okay, after ovulation, what happened? You see, it continues to thicken. Okay, it continues to thicken because they are preparing for the VIP, right? Okay, preparing for the very important gas, which is the fertilized gamete, waiting for the embryo. So they continue to prepare enough supply. Okay, if fertilization occur, you know progesterone level will maintain. Why? Kita baru bincang. We just discussed earlier slides, right? If fertilization occur, progesterone level will be high because corpus luteum will continue to maintain its size. So when progesterone is high, endometrial wall will still maintain its thickness because we are preparing for pregnancy. But if fertilization do not occur, then corpus luteum will degenerate, progesterone level will drop, and that will cause shedding of endometrial wall. So that's going to push this endometrial wall. Okay, what teacher did in previous slides, okay, I showed you the changes for the hormones throughout the chart, and then I showed you the changes. So we looked into each of them separately. Okay, teacher showed you changes for hormones first, and then we looked into follicle and oocyte development, and then we looked into endometrial wall. Now I break it down, okay, one by one, so that it's easy for you to see the changes. But when you need to answer essay questions, how do you tackle essay questions? You cannot write them separately. Okay, when you tackle essay questions, you must write all of it. That means you must relate. Okay, we must be able to see the changes in the hormone level and the changes in the follicle growth as well as endo. Right, now let's apply what we studied into this very simple essay question. If question asks you to describe, okay, the changes in the hormonal level and follicle development during menstrual cycle. Okay, we start with day 0 with hypothalamus secreting gonadotrophin. This gonadotrophin will stimulate pituitary will to secrete FSH. FSH will stimulate follicle development. You can see the follicles growing bigger and larger. As the follicles are growing, they are going to increase release of estrogen. As estrogen increases, estrogen going to promote gonadotrophin to release again, to stimulate again pituitary, but this time to release LH. So you can see LH increasing. When LH reaches its peak, it is going to stimulate ovulation. Graphene follicle rupture, releasing the secondary oocyte. After ovulation, this empty bag will become corpus luteum. It will form corpus luteum. Corpus luteum secretes estrogen and progesterone, so you can see level of progesterone increasing. When progesterone increases, you can see it inhibits or suppressing all other hormones. Okay, you can see here your LH, your FSH, okay, is in a lower level. Okay, you can see when estrogen increase, the other hormones are all lower. Okay, it inhibits other hormones. Okay, at the same time, it also promotes thickening of endometrial wall. The higher the progesterone level, the thicker the endometrial wall. Now let's see what happened after that. If there is no fertilization, then we can see corpus luteum degenerating, becoming smaller. So that will cause decline or drop in progesterone level. As progesterone level drops, and what you're going to do, I'm going to go through the essay one more time, this time slowly, okay, so that you understand what's happening, okay, how to relate all these three components: hormone, follicle and endometrial wall. So we start from the beginning of the menstrual cycle, where hypothalamus on day 0, hypothalamus releases gonadotrophin, releasing hormone. This will release FSH. When FSH is stimulated, when pituitary is stimulated, to release FSH, FSH will stimulate development of follicle. So follicle starts to grow. As follicles are growing, okay, they will release estrogen. And this estrogen will start to repair the endometrial wall. Okay, it starts to repair the endometrial wall. So you can see the endometrial wall slowly getting repaired. Okay, next, as the estrogen level increases, okay, it is also going to stimulate your hypothalamus one more time, okay, to increase level of LH. So what is going to do here is that it is going to promote your hypothalamus to release more gonadotrophin. Gonadotrophin going to stimulate pituitary to increase LH. So that's why you can see the. We continue with the remaining part of the graph. Okay, I take from where I stopped just now. Okay, where at the peak level of LH. Okay, so again repeating what happened. When estrogen level is very high, hypothalamus is stimulated to release gonadotrophin. Gonadotrophin stimulate pituitary to release more LH. That's why you can see LH at very high level here. When LH is very high, it is going to stimulate ovulation. Okay, when LH rises, it leads to ovulation. Let's define ovulation: release of secondary oocyte from the graphene follicle. Okay, graphene follicle ruptures, releasing the secondary oocyte into fallopian tube. Okay, now what happened after ovulation? Graphene follicle will form corpus luteum. And this corpus luteum will continue to release estrogen and progesterone. So you can see estrogen level increasing. Right? Okay. Estrogen level increases. So what happened? When a progesterone level increases, okay, estrogen and progesterone increases, okay, first thing, it is going to inhibit, which means it is going to suppress all other hormones at low level. Okay, inhibit, it will slow down release of FSH and LH. So you can see all of them here at lower level. Okay, next, it is going to promote okay, if let's say there's no fertilization, let's say, okay, if there's no fertilization, then what happen? LH level will decrease. Okay, you can see here LH level starts to drop, progesterone drops, and LH will also drop. You can see here LH also drops. Okay, so this, when the progesterone drops especially, this will have direct impact on the endometrial wall. Endometrial wall starts to break down. It starts to shade off as well. Okay, and this will be the beginning of the next menstruation. If fertilization happen, okay, right, if fertilization happen, then progesterone level will be maintained at a very high level, right? Okay, if fertilization happen, what happened to corpus luteum? Corpus luteum will maintain. When corpus luteum maintain, okay, so now that we looked into each of the phases separately, let's combine the essay one more time. Okay, teacher prepare short notes for you to help you with the essay. Okay, to relate all the hormonal level, follicle development, and endometrial thickness. Okay, let's start with day 0. What happened at day 0? Hypothalamus secretes gonadotrophin. And this gonadotrophin will stimulate pituitary to release FSH. So what happened when FSH is released? It will stimulate follicle growth. Okay, FSH stimulates follicle growth. Okay, you can see the follicles are growing. Okay, you can see the follicles growing. Okay, next what happened? As the follicles grow, they are releasing estrogen. So you can see estrogen level increase here. Okay, estrogen level increase. When estrogen level increases, okay, what it will do to FSH and LH? It will also increase FSH and LH. Okay, so you can see a surge in LH. Estrogen increase. Gonadotrophin will be stimulated again one more time, this time to increase LH. So you can see LH continue to rise. Well, LH rises, it is going to promote or stimulate ovulation. Okay, ovulation occurs on day 14. Okay, ovulation on day 14. What happened after ovulation? Graphene follicle will form corpus luteum. The empty bag forms corpus luteum. This corpus luteum will secrete estrogen and progesterone. So it is going to reduce release of FSH and LH. Why? Now one follicle is out, right? So they want to focus on this one follicle. They want to prevent other follicles from coming out. That's why FSH and LH value will drop. Okay. Now estrogen and progesterone will increase. When estrogen and progesterone level increase, you can see endometrium wall increasing as well. Okay, thickness of endometrial wall also increases. You can see here, it starts increasing. Okay, as progesterone increase, endometrial wall increases too. Okay. If there is no fertilization, let's say if there is no fertilization, then what happened here? LH will decrease. Corpus luteum starts to degenerate, also becomes smaller. Estrogen and progesterone starts to drop. So semua pun turun. All goes down. LH drop, corpus luteum drop, progesterone and estrogen also drop. Okay, this will result in menstruation. They're preparing for the next menstruation stage. Okay, but on the other hand, if fertilization do occur, okay, let's say fertilization happens. Okay, if fertilization happen, then what happen here? Corpus luteum will maintain, right? Okay, corpus luteum will maintain, so it is still big. When it is still big, it continue to release more and more estrogen and progesterone. Okay, progesterone also high, and that will maintain endometrium wall to be thick as well. So for number 9, semua pun naik. Okay, if fertilization occur, corpus luteum maintain big, progesterone level is high, endometrium wall is thick. Okay, now these short notes are for you to relate all three together: the hormone, the follicle development, and also the endometrial wall. So with that, I have managed to, today teacher managed to discuss all three components. Okay, we looked into definition, we looked into all the hormones related to your menstrual cycle, and we also looked into changes that happen throughout your endometrial wall, changes throughout hormonal level, and how it affects follicle development. Whatever short notes I gave you, I hope it helps you, okay, to master this subtopic, as it's very important for your upcoming SPM examination. It was so nice sharing knowledge with all of you, and till we meet again very soon in next episodes. Okay, thank you very much, and all the best for your SPM.
Corpus luteum. And now, for our next question, that is question A2. The question is, name the hormone that stimulate X to secrete progesterone. So this question is 1 mark. Alright. So X is corpus luteum that secrete progesterone. So to answer this question, you must be able to relate the hormone level to the development of follicles in the ovary. So how many hormones level that you need to know? There are 4 hormones level. Okay, we have follicle stimulating hormone, we have luteinizing hormone, we have estrogen, we have progesterone, which is this one. So now you have to know which hormones that stimulate X, which is corpus luteum, to secrete progesterone. The answer is, for 1 mark, yes, luteinizing hormones. Okay, good. Now, let us continue with our next question. Question B. Question B is a question where they give you an issue, they give you a situation. So you need to study the situation and find the aim of the question, what the question really asking you. Okay, for question B, let us read the question. Luteal insufficiency is a condition where eggs fail to secrete progesterone. Explain the impact of this condition on pregnancy. Okay, even though you don't know, maybe you are not familiar with luteal insufficiency, and that's okay. But at the end of the sentence, you can see that eggs fail to secrete progesterone. That's our main issue. Eggs fail to secrete progesterone. So, why or how the progesterone level affect the pregnancy? Alright, so before you answer this question, first of all, you need to understand what is the function of progesterone. Put that in your mind. The function of progesterone, the basic function of progesterone is to maintain the thickness of the endometrium. Maintain the thickness of the endometrium. But in this case, eggs fail to secrete progesterone. By means, progesterone level decrease, progesterone level drop, progesterone level not enough, not enough progesterone. So how it will impact or affect the pregnancy? Okay, for this question, we have 3 marks. So the first mark is very important, is to state what happened to the pregnancy. That will be our first mark. What happened to the pregnancy? And the other 2 marks is to explain the things that happens to the pregnancy caused by the lack of progesterone. Okay, let us take a look at the answer. Alright, our first answer, like I said earlier, is to state what happened to the pregnancy. There will be no pregnancy occur, or there will be miscarriage happen if there is a pregnancy. Why is it so? Let us rewind back the function of progesterone. Function of progesterone is to maintain the thickness of the endometrium. But in this case, eggs fail to secrete progesterone, so the level of progesterone drop, not enough, decrease. Thus, thickness of endometrium cannot be maintained. That is will be our second point of explanation. And then, what happened when thickness of endometrium cannot be maintained? Endometrium will shed or collapse. And what happened? Embryo cannot implant, or embryo implantation cannot occur. So there are 4 points, maximum 3 marks. The first mark must state what happened to the pregnancy, and the other 2 is to explain. Alright, let us go to our next question. Question 2. Diagram below shows the formation process of secondary oocyte in human ovary. So, formation process of secondary oocyte. This is our secondary oocyte. Alright. So, can you name the process of formation of secondary oocyte? Yes, oogenesis process. Okay, let us take a look at the first question. A1, which consists of 2 marks. From the diagram shown, name process X and the stage of chromosome division in the secondary oocyte. Process X. So where is process X? Here. Occur after the meiosis 1 complete. I think everybody knows what is process X. Okay, so for this question, why we have 2 marks for this question? Because we have 2 questions here. We have to name the process X, 1 mark given there, and you need to state the stage of chromosome division in the secondary oocyte. That will be your second mark. So what is process X? Process X occur after the meiosis 1 completed? Yes, the answer is process X is meiosis 2. And they want to know, the question want to know the stage of chromosome division in secondary oocyte. I mean the stage in the meiosis, where the secondary oocyte stop during the meiosis 2. The answer is metaphase 2. Secondary oocyte stop at metaphase 2 during meiosis 2. Okay, 2 marks given there. Now for question number 2, A2. Explain one difference in the number of chromosome in the oogonium and the secondary oocyte. So where is oogonium? Here. Where is the secondary oocyte? Here. So for this question, they want you to state difference, one difference, and they need you to explain the difference. The question need you to explain the difference. So here there will be 2 marks. One is for the difference in the number of chromosome between oogonium and secondary oocyte, and the second mark is for the explanation. Okay, so what is the difference in the number of chromosome in the oogonium? It been stated here. You can see oogonium is 2n, or we call it as diploid. Diploid. And the secondary oocyte you can see here is n, or haploid. That will be our difference. Oogonium has diploid number of chromosome, while secondary oocyte has haploid number of chromosome. So when you answer a question that asks you to give a difference, you need to write the difference in one sentence. You need to state the difference in one sentence, like this one. Oogonium has diploid chromosome, while secondary oocyte has haploid chromosome. Okay, second answer for this one, why I give oogonium has 46 chromosome while secondary oocyte has 23 numbers of chromosome, because the question also state this is a human ovary. So 46 number of chromosome is a diploid number of chromosome in human. 23 numbers of chromosome is a haploid numbers of chromosome in human. So these answers also accepted. Okay, now we have the difference. Next, for the second mark, you need to explain the difference. Okay, difference, explain the difference by means why oogonium is diploid, why secondary oocyte is haploid. Simple. You can see that oogonium form when primordial germ cell undergo mitosis. You get the oogonium. And for the secondary oocyte, the primary oocyte undergo meiosis, or complete the meiosis 1 and obtain and form the secondary oocyte, which is haploid. Everybody knows in chapter 6 form 4, where the function, one of the function of mitosis is to maintain the number of chromosome. Diploid, diploid. And then for the meiosis, we know that the function of meiosis is to reduce the number of chromosome into half. So from 2n, diploid, it becomes n, haploid. Okay, so you have 2 marks here. Alright, now let us continue with our next question. Okay, question B. Explain the relationship between the increase in FSH level, follicle stimulating hormone level, and ovulation. So now you need to relate the follicle stimulating hormone level to the ovulation process. Alright, what is follicle stimulating hormone? Is a hormone that stimulates the follicle development in the ovary. That's why its name is follicle stimulating hormone because it stimulates the follicle development in the ovary. So how it is related to the ovulation process? So this question we have 3 marks. So the 3 marks you need to include the explanation how FSH level end up with the ovulation process. Okay, let us take a look at the answer. First answer, first step, FSH or follicle stimulating hormone stimulate the development of follicles in the ovary. We know that. And then what happened? Follicles that develop in the ovary secrete estrogen. And then high estrogen level stimulate pituitary gland to secrete luteinizing hormone. And then what happened? Luteinizing hormone will stimulate ovulation. And then what happened during ovulation? Secondary oocyte released during ovulation. So that is how the follicle stimulating hormone level affect or relate to the ovulation process. You need to answer this question step by step. Alright, so we have 5 points here. Maximum is 3 marks. Okay, now to the next question is a compare and contrast question. Compare and contrast question or comparison questions. How to answer this kind of questions? Compare and contrast questions or comparison questions is where you need to write both similarities and differences in order to get full marks for this kind of question. So how many marks given for this question? 6 marks. In order to get 6 marks, full marks, 6 marks, you need to write the similarities and differences. Now, let us read the questions. Compare and contrast the spermatogenesis and oogenesis process. So, what is spermatogenesis? Process that produce sperms. Oogenesis is a process that produce secondary oocyte. Okay, like I said earlier, in order to answer this question, you must write similarities and differences. Let us start with similarities. How to write the similarities? Look at the sample answer. You need to state both processes because it is a process. Both process. Why both? Because you have 2 processes. Both process occur in reproductive organs. Both process produce haploid gametes. If you didn't write both, you can write also spermatogenesis and oogenesis process occur in reproductive organ. Spermatogenesis and oogenesis process produce haploid gametes. That is how you write it down for similarities. Now, let us go to the differences. At least you need to give 2 similarities. Now, let us go to differences. Now, how to write down the differences? When you write down the differences, you need to differentiate it category by category. For example, okay, so we have the spermatogenesis process, we have the oogenesis process. So how you write it down in an essay, or this is in a table form, or how you write it down in an essay. For example, spermatogenesis process occurs in testes while oogenesis process occurs in ovary. Full stop. That is how you write it in a sentence. Okay, category by category. Now, the second category, it must be in the same category. Spermatogenesis process, where spermatogonium will produce 4 sperm and in oogenesis process, oogonium produce 1 secondary oocyte and 3 polar bodies. Spermatogonium, oogonium, same category. Next, differences. Two secondary spermatocytes produced after meiosis 1 in spermatogenesis process, while in oogenesis process, one secondary oocyte and one polar body produced after meiosis 1. Same category, meiosis 1, meiosis 1. Now next, in spermatogenesis, meiosis process is completed, while in oogenesis, meiosis or meiosis 2 only completed when sperm fertilize the secondary oocyte. The next category is about meiosis. Meiosis. Okay. Next, sperm production continue from puberty until old age in spermatogenesis, while in oogenesis, secondary oocyte production continue from puberty and stop during menopause. This is the duration of spermatogenesis and duration of oogenesis. Same category. Next, in spermatogenesis, spermatid undergo differentiation, while in oogenesis, secondary oocyte does not undergo differentiation. Same category, differentiation, 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 differentiation. And then next, in spermatogenesis, millions of sperm form every day, while in oogenesis, only one secondary oocyte released in every menstrual cycle. Same category, the numbers of gametes in spermatogenesis and the numbers of gametes in oogenesis. Okay, that is how you write or how you answer the compare and contrast question or comparison question. Make sure you give the similarities and the differences. Okay, next question. Question number 3. Diagram below shows a graph of hormonal changes during the menstrual cycle, the graph, and with the changes in the ovary, which is the follicles here, and the uterus thickness. Okay, the question A1. Identify hormone Q and S. Where is Q? Here. And S here. So how to answer this question? It's very simple. You can refer to the follicle as your hint, as your clue. So you can see when Q is at the higher level, Y process occur. Secondary oocyte is released. So this is ovulation. Ovulation occur when luteinizing hormone is at the highest. Okay, so how about S? S, you can see it is produced or at the highest when the follicle is in form of Z, which is Z formed after the ovulation process. So we know that Z is corpus luteum, and corpus luteum produce progesterone. And then you can see the thickness of the endometrium here is maintained. So we can conclude that S is progesterone. So let us check our answer. Yes, Q is luteinizing hormone, or you can write capital LH, and S is progesterone. Now, next question, question number 2. Diagram above show the development of follicles in X until the formation of corpus luteum in Z. Formation of follicle X until it becomes corpus luteum, which is follicle Z. Explain the event X, Y, and Z that which involve follicle stimulating hormone, luteinizing hormone, estrogen, and progesterone. All the 4 hormones. How X, Y, and Z are involved with this hormone. How this hormone affect the X, Y, and Z. Okay, let us take a look at the explanation. In X, primary follicle develop into Graafian follicle that's stimulated by the FSH, follicle stimulating hormone, that cause the primary follicle to develop into Graafian follicle. That is our first point. Second point, what happened? When the follicle develop, the follicle will secrete estrogen. The development of follicles stimulate the release of estrogen. Now we already state the second hormone. And then when estrogen level increase, it stimulates the release of FSH and LH, especially LH, luteinizing hormone. Where now why is the ovulation process occur? Ovulation process occur when luteinizing hormone is at the highest level. Alright, and then what happened? After the ovulation process, follicle Y turns into follicle Z, that is the corpus luteum. Corpus luteum will secrete progesterone. Corpus luteum is stimulated by the luteinizing hormone to secrete progesterone. And then combination between the progesterone and estrogen inhibit the release of FSH and LH. The combination of estrogen and progesterone inhibit the release of FSH and LH, follicle stimulating hormone and luteinizing hormone. So you can see the luteinizing hormone decrease here, and the follicle stimulating hormone also decrease here because of the combination between estrogen and progesterone that inhibit the pituitary gland to release the follicle stimulating hormone and luteinizing hormone. So that is how you relate the four hormones with the developments of follicles in the ovary. Now let us continue with the next question. Next question is the objective question. Which of the following hormonal levels stimulates the ovulation process? So the given hormones here is FSH, follicle stimulating hormone, and LH, luteinizing hormone, with a different level. A is high follicle stimulating hormone that lead to ovulation. B, low follicle stimulating hormone. C, high luteinizing hormone. And D, low luteinizing hormone. So what is your answer? Yes, the answer is high luteinizing hormone. Very good. Now, let us take a look with our second question, which is our last question. Question number 2. What happened to the endometrium wall when corpus luteum degenerate? Okay, A, endometrium wall will shed. B, endometrium wall thicken. C, endometrium wall rich with blood capillaries. So what will be your answer? Yes, the answer is A. Endometrium wall will shed. Why is it so? Corpus luteum, its function is to secrete progesterone. So when corpus luteum degenerate, progesterone level decrease. Progesterone level drop. Thus, endometrium wall will shed. And then we already at the end of the slides. Well done, you guys. Thank you and see you guys again next time.